Hi, this is Teresa Millette reporting for ATM 101 on Unit 15 about the climate in Kodiak, Alaska. The first question we addressed is, do the changes in the average temperatures reflect the seasonal changes at Kodiak? I would say yes. Our book covers the surface albedo effect in that significant changes occur seasonally and affect the fraction of incident solar radiation that is converted to heat. In autumn, September and August, typically in Alaska, the loss of leaves from trees raises surface albedo. At middle and high altitudes, the increase in surface albedo accompany the winter freeze over of lakes, formation of sea ice, and development and persistence of snow coverage. As there is less sun on average in the winter climate, the average max temperature is lower. Summer temperature is about 50 degrees Fahrenheit, looking at our surface air temperature maps that are provided to us. Beginning in September and October, temperatures begin to drop on average to a low 40s, 40 degree Fahrenheit. Our weather maps reflect the change in temperature, so I believe that yes, the changes in average temperature reflect seasonal changes in Kodiak. Looking at the second question that we investigated is, for both weeks, if the temperatures are warmer than climatology, does this represent clear skies or cloudy conditions? I would predict cloudy conditions. As the sun's rays uh, warm the atmosphere, the clouds prevent some of the rays from escaping, thus warming the temperature slightly. The clouds reflect some of the warmth back to the earth as the sun goes down, creating warm temperatures. At the same time, it could be clear in the daytime and cloudy at night, which traps some of the sun rays and slowly releases it uh, to where there is no heat. The third question we investigated was, how do sky conditions, clear, cloudy, and partly cloudy, affect the daily range of temperatures? Clear skies mean a lower max temperature because the Earth emits heat rapidly into the atmosphere. As the skies become partly cloudy, temperatures rise slightly during the day as the sun is out and typically directly overhead during midday. If skies become cloudy, they trap more heat between the surface and the atmosphere, the surface of the Earth and the atmosphere. So in reality, it stays warmer longer in relation to a heat that dissipates quickly because there is no blockage that's trapping the heat. Over a 24-hour period, surface air temperature responds to regular variations in the flux of radiation. With clear skies and light to calm air or wind, the lowest or minimum temperature typically occurs shortly after sunrise, after solar radiation equals outgoing Earth radiation. The day's highest or max temperatures is usually recorded in early or mid-afternoon when outgoing Earth's radiation equals incoming radiation, even though solar radiation peaks around the local sooner noon. So I would say that clouds have a great effect on climate range, especially maritime climate where the humidity and precipitation is so high and you do have a lot of cloud coverage in the area. The fourth investigation question was, how do the changes in humidity reflect the changes in weather relating to dew point and relative humidity? At constant temperature and pressure, the relative humidity varies directly with the vapor pressure mixing ratio. Relative humidity increases as water vapor is added to the air as long as the air temperature and pressure remain constant. Because of saturation, vapor pressure varies directly with temperature. The relative humidity varies inversely with temperature. If no water vapor were added to or removed from unsaturated air, the relative humidity increases as the temperature drops and decreases as the temperatures rise. Related to dew point, while the relative humidity gives a percentage of how humid air is compared to if that same air were saturated, dew point directly measures the water vapor content of air. The higher the dew point, the greater is the concentration of water vapor in air. Cooling unsaturated air at constant pressure increases its relative humidity. When the relative humidity reaches 100%, the air is saturated and the air temperature is the same as the dew point. Warming the air without adding water vapor via evaporation lowers the relative humidity and increases the difference between the actual air temperature and the dew. On question 5 is, based on your analysis, which of the weather conditions that occurred best represent the Kodiak climate. I have not had the pleasure of ever visiting Kodiak, but from our investigation, I would say because of its a maritime climate, it's humid. There's followed by a lot of precipitation. The precipitation water source is not too far. Obviously, it's surrounded by water, but I would just say the best weather condition that I can describe is humid, cloudy, and a lot of precipitation, which from our investigations from September on and October on our weather maps, it shows that it's partly cloudy with chances of snow and rain in all the days that are covered on our weather maps. Question 6 is states, based on your analysis, would clear weather in Kodiak result in a colder or warmer climate in September and October slash November? Based on my investigation, I would have to say that it would be a warmer September because it's in their fall stages, but or no, I'm sorry, let me switch that. A colder in August and September, but a warmer in October, November. Based on our temperature readings, we can see that it's higher in these periods, but based on my research on the web, I saw that their average temperatures were lower. That's typically their winter months, but we on the snow investigation we just did, we kind of figured that snow is warmer than the outside temperature, so in reality it's possible that it could also warm the air temperature that's surrounding it.